Hello, and welcome to a hands-on demo of the Attributor gem. This screencast gives a hands-on introduction of a few of the use cases and common concepts that one will need to know to have a solid grasp on how to best utilize the gem. So for this, we will focus on the struct type, which is possibly the most commonly used one, as it really provides an envelope under which you define sub-attributes and has basically the bigger substructure. In other screencasts, we will dive deeper into the details of other types. So to get a quick peek, if you go to the Attributor repository and click on the wiki section, here you go. This is what a struct definition for a hypothetical blog class will be, and that you can see that you can glance that sort of has several attributes defined for a blog of different type, and each type has a bunch of different options. So we're going to go through creating a struct similar to this. So let's get into the an editor. So what I want to do, let's simplify that and let's try to define a structure for a person. So what we want to end up once we have this type is something like a person class, and in which we define attributes, so ID, name, and things like that. Once that's done, we want to be able to use this class like any other Ruby object. So for example, I want to say I want to create an instance of this. I want to be able to set the ID, and I want to be able to print it out, access it through the method name. That's the type of things. And then we want to do all the other great things that Attributor itself is going to allow us to do, like validation, coursing, and many other things. So let's try to get to this situation first. So how do you define attributes? Well, we said that the class person needs to behave like a struct. Therefore, the first thing we need to do is to derive the class from an attributor struct that will give us that field. And then what we need to do is start defining the attributes. And then we define the attributes one by one. And let's keep it simple. Let's assume that we have, say, an ID, that it's an integer, an attribute that is a name, makes sense, as a string. We may want to have an attribute that gives just the sex of the person, which is also a string, and one last one just to get a little more variety that says if it's a organ donor or not, and that will make it an attributor boolean. Okay, very simple. So now we have a class, and what we want is to be able to use it like we said before. So if I do I could do person new and then set the ID, and I can print it out. For example, p inspect. So if I run this code, I'm going to see the output down here. So if I run this code, I have some sort of an instance of a person, right? Every attributor type has a method that is called dump that will convert the whatever type it is, the structure of the type it is, into primitive Ruby types. So in this case, it's going to be a hash with several attributes. Okay, so since I've only set the ID, helps if I actually set the ID. I will get a hash that has the ID that is an integer. Typically, you don't set them one by one, so there's a method that is called load that allows you to set a bunch of things at the same time. So for example, I can set the ID 123, the name John, and I don't care about the rest. I don't need to set them all, for example. So if I load these values into a person class, I'll get a person instance, and I'm going to dump that instance. So in that case, if I run it, I get what I expect. Okay, so there's an interesting thing that that can happen that is different from a normal struct, and that is that because we've defined this ID type to be an integer, every type has a different ways of coursing things into the right native type. So in this case, if I set the ID as string 1 to 3, you can see that it's going to load it, and when I dump it, you'll see that it's correctly converted into a string. Obviously, if I try to set something that doesn't, cannot be coerced, I'll get an error telling me so. Integer from value this, in value for integer. Okay. Okay. So now let's make this person a little more interesting, because at the end of the day, other than the coercing, we can see that this is not that different from a normal Ruby struct. So let's see what we can do when we define an attribute. There's several things that several options that one can use when defining an attribute, and some of them are common to any type of attribute. So for example, these 5 options can be used in any attribute that you define, regardless of the type that they belong to. For example, I can add a description to the ID attribute, a human description, identifier, something like that. I can also say if it's required or not. I can say this attribute is always required when I'm loading, when I'm trying to validate this object. I can also say what values a given attribute can take. For example, this will make sense here. Values, male and female, for example. I can also say what is the default value to use if it's not been passed in. For example, I can use, I can say that by default the donor is false. And I can also provide an example of a value for an attribute. For example, I can say for a name, this is the, I can say John Smith is the value that I want. And the examples are used. You can generate documentation and things like that. We'll get into that a little later. So those are the 5 different options that any attribute can take. Now, depending on the type of the attribute, there's some extra options that they support too. For example, integers support min and max. So I can say, this is a positive ID always. Or what else is important? For example, strings can take a regex option that can say what is this string, what the string match. So this could be, say, a word, and this is the only Smiths. We only want Smiths here. So there you go. Now when you have this suddenly this person is a little more interesting than what we had before, and we can continue doing the same thing. So person dot load ID 123, name Sally Smith. What else do we have here? Sex female. Okay, so I load this, and maybe then I dump it. I print dump. So what do I get? I get a struct, sorry, a hash with the right values based on what I've done, including the donor. Although I haven't set the donor, but because it has a default value, it's included in the output. Now, once I have this more interesting definition, what I can do is validate the content of this instance. So let me put a separator, something like that. And if I run this, I should get no errors, an empty array of errors, because all the values that I've added are actually in line with what I've defined. But if I start messing with this and say, for example, I have said that the ID is required. So what if I don't pass the ID and rerun this? Suddenly I get attribute ID is required. Now this dollar represents the root of the structure that I'm defining. If I want to change it so that it's a little more legible depending on what I'm building, I can pass a context, a root, let's call it person. Okay, rerun it again. It's going to, now the root is person. So now it's even easier for me to understand that the ID of the person is a required attribute. Let's assume that my name is also not Smith, but Doe. run it again, and I should get two errors. One, because the ID is not there, and the second is that the name with this value does not really match the expression. Now let's do one more. Let's assume that I pass an unknown value on the sex, which is not within the allowed range. Run it again. I have now three errors. ID is not there, the name doesn't match the expression, and the sex with value unknown is not within the allowed values, male or female. So now you see that all this validation and the error reporting is something that you get for free in a very consistent way. Okay, so in this case we've used really simple, well, sort of simple attributes inside the person, but this can really go nuts as you want. You can have, say, for example, let's just say timestamps, a structure of timestamps that have, like, one is created at, it's a date time, and the other one says the updated at. So this is a way to define a substruct inside a struct. Almost equivalent to say this attribute is a struct, and I'm defining its structure in line here. Okay, it's a very easy way to do struct. And this can go, I can have another substruct here and all that stuff. Okay. Other things that show a little bit how this can be expanded. You can have a collection. This could be like a simple collection of tags. It could be an attributor collection of strings, right? It's an array of strings, and that's the attribute that we want here. Or you can go further and do something like you can have an attribute that is friends, which is a collection of person, people. Right? Now note that this is an interesting one because we're defining a class, but we're already using it within this definition. So there's a bunch of logic inside that allows you to do these circular references whenever they're possible. So this is just an example of how you could define many different substructures inside a struct. So once you have that in place, then all the the validation and description and requirements apply in the same way. All this, this can be required or not. It all applies in the same way. You can describe every single thing. You can give examples, and so on and so forth. So let me give you a couple more interesting tidbits that are very useful once you have attributor types defined this way. One thing that you can do is to automatically generate examples, right? In this case, if I wanted to show you an example of a loaded data in here, I would have to basically do, input a lot of things, IDs, name, and sex, donor, timestamps, and all that. Instead, a lot of the times it's really nice to be able to generate examples that are really instances of the object with the right values set in that match your definition. So that's what the example at the class level function will allow you to do. So I can say, attributor, give me an example for a person that matches your definition. So then I can actually print the example. Now this is going to be really long, so let me maybe start commenting out some of the attributes here to begin with. So let me generate an example and dump it. So look what happened here. Without loading anything, the system has loaded for me a set of data that matches my definition. It's an ID, a name that actually has my example, a sex that is within the allowed values, and the required donor default as true. That's an interesting one. Well, I guess it could be true or false. That's just the defaults, but it's going to set it up. So if I uncomment this part here, now the example is going to be more featureful, right? It also knows how to generate the timestamps, which is a subhash with some dates. Okay, and I can do automatically this thing in the same way, except that this is going to be pretty big, right? I'm going to see that um, the friends is my friends collection is an array of full people uh, as I define them. Basically, you can very easily generate full-fledged examples that you can use in your documentation, in your tests, especially to populate a database, etc., etc. Now, let me put this back into a more sane demo situation. So every time I click uh, run, I'm going to get a different example. Sometimes I want the example to be generated in the same way, and I can pass a context seed basically when I generate the example, so that every time that I generate it is going to be the exact same number, the exact same example. Okay, that's also very nice to be able to generate the same set of examples for, say, the documentation purposes, right? You don't want to change all your examples only because you added a few fields or every time that you regenerate them. Now, a funny thing here is that this John Smith is always the same because I've set my example here, but just know that you can actually, this takes a lambda, so you could do things like using this gem, for example. You can say first name Smith, right? Smith. So suddenly, if I take the seed, oops, well, even with the seed, every time that I generate an example, I get a first name that is mapped to my name attribute. Now, one also very interesting thing that it's worth noting along with the example is that you can describe these types in JSON format so that automatic tools can read the definition and interact with them in a very easy way. So this is as easy for me to say person describe. So if I print the description and I pretty generate, we'll see, well, not pp, but we'll see that I get a long description of what this whole type is. Things like this is the name and the ID, the list of attributes that I've defined. For example, I have the ID attribute with all the description, the requirements, the options, what type it is, etc., etc. Okay, so it's a way to easily define the structure of what you've defined in Ruby, export it as JSON so that other tools can actually take advantage of it. And last but not least, I want to also talk about the specific struct option that allows you to do a little bit of an inheritance situation here. So for example, if I go back to my simple person, I may want to have another class that has most of the attributes of a person but not all of them, and I don't want to have to redefine them all. So this is not the best example, but say for example I want a female struct that has the ID and the name of a person, and I don't care about the rest for whatever reason. Okay, so this is kind of what I want to do, because I don't really want to have to redefine, oh, this is actually an integer and the description is whatever description and these options are the right options. So I kind of want to do this, and you actually can do that if you just say these attributes have a reference class which is the person. So if you have a reference class that is elsewhere, you can shorten the definition of the attributes, because the integer, the description, the requiredness, all that is going to be inherited. So if I have that, I can, let's do a quick thing. So I can generate an example for a female. I can dump it, and you'll see that it has the right things. It has an ID that is an integer, and it has a name that matches what I've explained in here. Now this can be done not only at the top level class, but you could do it inside a substructure. For example, twins. So if I have a twins class that has, say, I can say attribute twin1. I can simply say this is a person. So that's really, these attributes the full person. We've seen that before, like in the collection. But I could say the twin, I could have said it in a way that it says twin2 really only want, the ID and the name attributes of a person, very much like we did here. So we can do exactly the same thing in this sub attributes. It's basically I'm inlining a struct, and I'm telling it, by the way, inherit from this person. So if I get an example for a twin and run it, now you'll see that I have to put the right class names. Now you'll see that you get twin1 is a full person, twin2 is a compatible person, but only for the attributes that I've defined. I could have overloaded things like max, so min 0. Okay, so min 100. So I can override certain attributes, and if I rerun it again, it's kind of difficult to see, but it would never go down to 100. Okay, so that's an easy way to inherit certain things, because a lot of the times you have the similar structure from which you're getting a few of the attributes, and you don't want to have to repeat everything all over again, all the options, all the descriptions, requirements, and stuff like that. Well, so that's it for a quick run through about the basic concepts that the Attributor gem brings about. We've seen that it allows you to describe your types in great detail and map them to pure Ruby classes. It takes care of the coercing of the values. It validates the contents of the objects and consistently report the encountered errors. It can generate as many automatic examples as you need from your definitions, and it can even output a schema description of the types in JSON format as a way for external tools to parse and interact with your interfaces. I really hope you've enjoyed it.